Let's continue exercise 7.4. Question number 13. Integral 1 divided by root of x minus 1 multiplied by x minus 2 dx. Just open the brackets and multiply. Get the expression. Minus 2x minus 1x is minus 3x. Minus 1 times minus 2 is plus 2 dx. Let us complete the squares. Here the coefficient of x square is 1. So easy to complete the squares. A term is x. Here 2ab term is negative. So minus sign in between. To find b, divide the coefficient of x by 2. So 3 by 2. This is our b term. Now subtract b square term because this expansion gives you a square minus 2ab will be minus 2 and 2 will get cancelled. 3x plus b square term is 9 by 4. To cancel this, I have to write minus 9 by 4 and plus 2. Into dx. One divided by root of x minus 3 by 2 the whole square minus 9 by 4 plus 2, LCM is 4, minus 9 plus 8 becomes minus 1 by 4, which can be written as minus half the whole square into dx. And use the formula integral 1 by root of x square minus a square dx, which is log of absolute value of x plus root of x square minus a square and plus c. Log of absolute value of x here is x minus 3 by 2 plus root of x minus 3 by 2 the whole square minus half square plus c and expansion of this will give you x minus 1 into x minus 2, the original expression I have written, and plus c.
Or you may write root of x square minus 3x plus 2.
Question 14. Integral 1 divided by root of 8 plus 3x minus x square dx. Take minus sign common. Minus sign outside the expression but not outside the root sign. Without taking minus sign common also you can do, but this will be easier. Into dx. Now let us complete the squares. Minus of a term is x, 2ab term is negative, minus divide the coefficient of x by 2. So 3 by 2. This is our b term. Whole square, and we have to always do minus b square term, which is minus 9 by 4 and minus 8 dx. Minus 9 by 4 minus 8 becomes minus 9 minus 32, which is minus 41 divided by 4, minus of x minus 3 by 2 the whole square minus 41 by 4 can be written as root 41 by 2 the whole square. dx. Now let us distribute this negative sign. So it becomes root 41 by 2 the whole square minus of x minus 3 by 2 the whole square into dx. Now we will use 1 by root of a square minus x square formula, which is sine inverse of x by a plus c. Sine inverse of x in this case is x minus 3 by 2 divided by a is root 41 divided by 2, which is sine inverse of, take LCM, 2x minus 3 by root 41, LCM 2 will get cancelled, and plus c. Question 15. Integral 1 divided by root of x minus a multiplied by x minus b dx. It is similar to 13th question, but that was easier because numbers were given. Here, instead of numbers, we have a and b. Let us multiply x square. We will get minus ax minus bx. Take x out. So it is minus of a plus b into x and plus ab into dx. We'll complete the squares. 1 by root of a square term is x square, so a will be x minus. If the coefficient of x square is 1, completion of square is so easy. Just divide the coefficient of x by 2, that is your b term, a plus b by 2, the whole square, minus b square term, which is a plus b by 2, the whole square, and plus ab. Let us simplify this. Minus a plus b by 2 the whole square plus ab.
LCM is 2 square, which is 4.
Minus of a square plus b square plus 2ab and plus 4ab. Minus a square minus b square minus 2ab plus 4ab becomes plus 2ab divided by 4. Let us take minus sign out. A square plus b square minus 2ab divided by 4, which is minus of a minus b the whole square by 4, minus of a minus b by 2 the whole square. Let us write the simplified expression. 1 divided by root of x minus of a plus b by 2 the whole square, and that expression becomes minus a minus b by 2 the whole square dx. We will use integral of 1 by root of x square minus a square formula, which is log of absolute value of x, this is our x, plus root of this expression. This expression is same as the given expression, which is x minus a into x minus b, and plus c. Question 24. 24 and 25th are of this type. We will do those two questions and then we will do 16th onwards. Question 24. Integral dx divided by x square plus 2x plus 2. Let us complete the squares. If the coefficient of x square is 1, it is easy. X, 2ab term is positive, so plus. Just divide the coefficient of x by 2, 1, and complete the squares. Minus b square term and the constant term, which is 2. This is integral dx divided by x plus 1 the whole square plus 1. We will use dx divided by x square plus a square formula, which is 1 by a tan inverse of x by a plus c. 1 by a is 1, tan inverse of x here is x plus 1 by a is 1 and plus c. Therefore, the answer is tan inverse of x plus 1 plus c. The correct option is B. Question number 25. Dx divided by root of 9x minus 4x square. Let us take 4 out. We will take minus 4 out. Outside the expression, I am not taking outside the square root. Negative sign cannot be taken outside the square root. 4 can be taken. Okay, x square, this becomes minus 9 by 4x. 4 has been taken out. Minus sign cannot be taken outside the square root sign. Keep that inside and let us complete the squares. X minus, divide the coefficient of x by 2. So 9 by 4 by 2 will become 9 by 8, the whole square. Always subtract b square term, that is 9 by 8 the whole square, which is 81 by 64, and there is no constant term to write here. Half into integral dx divided by root of, this is 9 by 8 the whole square. I am distributing the minus sign and this term becomes negative. And let us use integral of dx divided by root of a square minus x square formula, which is sine inverse of x by a. Therefore, the answer is half into sine inverse of x, in this case is x minus 9 by 8, divided by a is 9 by 8, plus c. Take LCM 8 and simplify. Half into sine inverse of 8x minus 9 by 9 and plus c. The correct option is B. Now, before doing the rest of the questions, 16th to 23rd, we will learn the next method. Write it down in your formula notebook. If you have integral of the form px plus q divided by ax square plus bx plus c dx, or integral px plus q, a linear function in the numerator and a quadratic function in the denominator, it can be with root or without root. So the first step is, we take px plus q as a into differential of this quadratic term, which is 2ax plus b. That is differentiation of ax square plus bx plus c. Only this quadratic expression, plus b. Second step, we will find the values of a and b. While doing sums, I will explain how to find the values of a and b. we have two methods. We can equate the coefficients and then find a and b, or by giving values for x also we may find a and b values. Then split the integral into two integrals, I1 and I2. The third step, the first integral I1 should be done by substituting the denominator as t, and I2 by completion of squares. Complete the squares and use the formula. This is the method. And note, you may have integral of px plus q divided by ax square plus c. What is the difference between this first integral and this? There is no x term in the denominator. Similarly, you may have integral of px plus q linear term divided by root of a quadratic term without x term in the denominator. So we can follow the same method, but we can skip the first step. Directly we can go to the second step. So directly we can split this into two integrals, I1 and I2. And I1 should be solved by substituting the denominator as t, and I2 direct formula. No completion of square is required here because there is no x term. We have only x square and constant terms. So directly we will be able to apply the formula. Now questions 16 to 23, they come under this type. But 16th question is very easy. Integral 4x plus 1 divided by root of 2x square plus x minus 3 dx. Here if you notice, differential of the denominator, that quadratic term, see 2x square plus x minus 3. Differentiate 4x plus 1 directly, the differentiation is in the numerator. So we can use substitution method for this. We need not use the method which we learnt. So directly we have it in the numerator. Therefore, the numerator becomes dt and the denominator is root t. Or we could have substituted along with the root also. Okay, t power minus half dt. Use x power n plus 1 by n plus 1 formula. Minus half plus 1 becomes plus half by half plus c. Now substitute for t. T is 2x square plus x minus 3. Therefore the answer is 2 times root of 2x square plus x minus 3 and plus c. Question 17. Integral x plus 2 divided by root of x square minus 1 dx. If you notice, there is no x term here. So we have to use that note method. So we need not find a and b. The first step need not be done. Directly we will split this into two integrals. X divided by root of x square minus 1. And the second integral is 2 divided by 2 is a constant. It can be taken out. 1 divided by root of x square minus 1 dx. The first one should be done by substituting the denominator as t. Square both sides, differentiate both sides, Let us substitute integral x dx becomes t dt. Here the numerator x dx becomes t dt divided by root of x square minus 1 is t. Now the second integral. We are not using substitution for the second integral. The substitution is only for the first term. Here directly we can use formula. Integral of 1 with respect to t becomes t plus this formula is log of x plus root of x square minus 1 and plus c. Substitute for t. Therefore the answer is t is root of x square minus 1 and the second term is 2 times log of absolute value of x plus root of x square minus 1 and plus c. 18th question. Integral 5x minus 2 divided by 1 plus 2x plus 3x square dx. The first step is we have to write the numerator 5x minus 2 as a into differential of the denominator, differential of the quadratic function. It is 2 plus 6x and plus b. We have to find the values of a and b. We can equate the coefficients. Here it is 2a plus 6ax plus b. So let us equate the coefficient of x. On the left hand side, coefficient of x is 5. On the right hand side, coefficient of x is 6a. So we get the value for a. Now let us equate the constant terms. The left hand side constant term is minus 2. On the right hand side we have two constant terms, 2a as well as b. By substituting the value of a, we can find the value of b. A is 5 by 6 plus b. Therefore b is minus 2 minus 5 by 3. Take LCM, which is minus 11 divided by 3. So b value is minus 11 by 3. So first step is over. Now the second step is we have to separate the integrals into two. Let us first substitute the values of a and b. Look at this. Numerator 5x minus 2 can be written like this. Both are equal, right? So in the given integral, I am replacing, let us take the given integral as I. So I is equal to, the numerator can be replaced by this expression, a into, a is 5 by 6 into 2 plus 6x, b is minus 11 by 3 divided by the denominator, I will write it as 3x square plus 2x plus 1 dx. If you open the brackets and simplify the numerator, we get back the original expression. See, I will show. 5 by 6 into 2 is 5 by 3 plus 5 by 6 into 6x is 5x and minus 11 by 3. So 5x, take LCM, 3 is the LCM. We get 5 minus 11, which is minus 6, which gives you 2. We get the expression 5x minus 2, which is the given expression in the numerator. Okay, we substituted the values of a and b. Now the second step is we split this into two integrals. First term is 5 by 6, 2 plus 6x divided by 3x square plus 2x plus 1 dx. And the second term is 11 by 3. It is a constant, so I can take it outside the integral, divided by 3x square plus 2x plus 1 dx. So this is our second step. After substituting the values of a and b, we separate the integrals into two. The third step is, the first integral has to be done by taking the denominator as t, the second one by completion of squares. Let us substitute 3x square plus 2x plus 1 as t. Differentiate. We get the numerator, see? That's how we have split, okay? So 5 by 6 integral, the numerator becomes dt and the denominator is t, minus 11 by 3. I am taking 3 out from the denominator. It becomes x square plus 2 by 3x plus 1 by 3 dx. We have to complete the squares for the second term. I will write the integration step after completion of squares. 11 by 9 x plus, divide the coefficient of x. Coefficient of x is 2 by 3. Divide this by 2, which is 1 by 3, the whole square. Always subtract b square term and write the constant term which is there in the previous step, into dx. Now minus 1 by 9 plus 1 by 3, let us simplify. It becomes 2 by 9. 5 by 6 integral dt by t, minus 11 by 9 integral 1 divided by x plus 1 by 3 the whole square, and this becomes 2 by 9. 2 by 9 can be written as root 2 by 3 the whole square. So 1 by x square plus a square formula, which is 1 by a tan inverse of x by a. Therefore 5 by 6 log of absolute value of t minus 11 by 9, 1 by a. A is root 2 by 3. Tan inverse of x by a, and plus c. Substitute for t. 5 by 6. Here t is this log of absolute value of 3x square plus 2x plus 1, minus, let us simplify this, 3 could be cancelled, 11 divided by 3 root 2, tan inverse of, take LCM 3, which is 3x plus 1 divided by root 2, and plus c. Question 19, same method, 6x plus 7 divided by root of x minus 5 times x minus 4 dx. Let us multiply and write the denominator, which is x square minus 5x minus 4x is minus 9x, and 5 4s are 20. Same method. The first step is, we write the linear term which is in the numerator as a into differentiation of the quadratic term which is in the denominator. Don't consider that square root, only the quadratic term you have to take. So differentiation of this is 2x minus 9 and plus b. Now let us find the values of a and b. We will equate the coefficients. So by equating the coefficient of x, the coefficient of x on the left hand side is 6 and on the right hand side is 2a. Therefore a value is 3. Now let us equate the constant terms. Constant term on the left hand side is 7 and on the right hand side we have two constant terms, minus 9a and plus b. Put the value of a and find b value. minus 27 plus b, therefore b is 34. Let us take the given integral as I. Therefore, I is equal to, let us replace the numerator 6x plus 7 as this. So, I am writing 6x plus 7 as a into 2x minus 9 plus b divided by root of x square minus 9x plus 20. First step is over. Now the second step is separating this into two integrals. 3 times 2x minus 9 divided by root of x square minus 9x plus 20. Plus the second term 34 is a constant, can be removed outside the square root. Now the first integral has to be done by substituting the denominator as t and the second one by completion of squares. So let us substitute root of x square minus 9x plus 20 as t. Square both sides to remove the root sign. Differentiate. See, we get 2x minus 9 dx, which is 2t dt. Therefore, the given integral becomes 3 times integral 2t dt divided by t. Plus, the substitution is only for the first integral, not for the second one. Second one should be done by completion of squares. X minus, divide the coefficient of x by 2, which is 9 by 2, the whole square, minus b square term. B square term is 81 by 4 and plus 20 we have. Into dx. Minus 81 by 4 plus 20. Simplify by taking LCM. It becomes minus 1 by 4. Therefore, this becomes 6 1 dt plus 34 times integral 1 divided by root of x minus 9 by 2 the whole square. This simplified answer is minus 1 by 4, which can be written as minus half the whole square. Now let us integrate both the terms. This is 6t 34 times, and let us use integral of 1 by x square minus a square formula, which is log of absolute value of x. X here is x minus 9 by 2 plus root of this expression, x minus 9 by 2 the whole square minus half square and plus c. Substitute for t. T is root of, here it is, x square minus 9x plus 20, and the second term is plus 34 times log of absolute value of x minus 9 by 2, and if you simplify this expression, we get root of the original expression, which is x square minus 9x plus 20 and plus c.